Hi everyone. So happy to have you for today's session. And today I'm going to be talking about regression. So yeah, let me get a couple of my slides. Okay, so I do hope that you're going to enjoy this session. And if you have questions, do well to ask me. I'm always willing to answer. Okay. So at the end of the session, I hope that you'd be able to define regression models. So you know what regression models are, you know where you can use regression models, you'll be able to give some examples of regression models, and you'll also learn a bit about scikit learn. So you'll be able to tell anyone what scikit learn is and some of its applications. You also be able to build a simple linear regression model, right? Prepare your data for model building. You'll also be able to determine appropriate techniques, using data visualization methods. And at the end, I hope you'll be able to participate in the challenge that I'm placing out for you. So I'm going to be making some assumptions. So the first assumption is that you're familiar with processes involved in analyzing data. And then I'm also going to be assuming that you're familiar with data visualization methods and libraries, including matplotlib and Seaborn. I think those are the two common ones that you guys have been taught, right? So yeah, let's dive in. So, what's regression analysis or regression, as you call it? So, mathematically, right, it's a group of statistical methods that estimates the relationship between a dependent variable, which is the target, like what you want to predict, and one or more independent variable, which are the features. So, let me kind of paint a scenario. So, in a grocery store, right, there is a manager, and then this manager is in charge of monitoring how prices perform, right? What products customers are interested in, how often do they buy them, right? Would increase in the price affect the rate at which they are bought? All in that kind of scenario now. So in that kind of scenario, let me pick a product. I pick sugar, right? So and now the manager wants to predict the price of sugar, right? In times of inflation. So what happens if inflation comes? Like what would be the price of sugar? Now you know that for someone to buy sugar, right, a couple of factors actually affect the sale of sugar. And let me give an example. An example is the type of sugar. Is it brown sugar? Is it white sugar? Right? So some prefer brown sugar, some prefer white sugar. So you might also want to think about that. So compare, okay, how many times do they buy brown sugar? Like what kind of people buy brown sugar? The location of your store also matters, right? So the time, the season, also the form. Okay, is it cube sugar, is it granulated sugar, right? So all those kind of factors kind of affects the price. Also the brand of the sugar, that also affects the price of that particular product. So in this scenario, right, the target you want to predict is the price. So that price is the dependent variable, and the price is dependent on a couple of factors. Now, these factors that the price depends on is what they call the independent variables, or you call them the features. Now, they are independent because they are on their own, right? So the type of sugar it's on its own. It's not depending on whatever, right? Is it brown sugar? Is it white sugar? It's on its own, right? But then the price of that particular box of sugar, right, is dependent on, is it brown sugar, is it white sugar, is it cube, is it granulated, where is your grocery store located, right? What kind of season is it? These are like factors. So I hope you have like a better idea of what regression really is about. So you're just trying to like estimate, find relationship between dependent variable. Now, this dependent variable can actually be more than one. So it can be more than one dependent variable. So it can be that you're trying to predict the price and then the rate of increase. You're trying to predict the rate of increase of a particular product at a particular time, and then you're also trying to predict the price. So you can have more than one target, and then you can also have one and more than one independent variables. So some real life applications of regression, businesses use it to understand how advertising affects revenue. For example, a particular finance organization, right, decides to use video advertisement. So they want, they're spending a lot on advertisement. They want to see how this directly affects the kind of revenue they have. Okay, what if we use images? What if we use animations? How does this kind of make more money for us? That's the end goal. So they want to see how advertising affects revenue, right? So this is an application of regression, also measuring how fertilizer and water, affect crop yields. Okay, if I use this particular fertilizer, what is the amount of the crop yield, the amount I get at this particular season. If I use this amount of water, like what is the yield? Also in predicting stock market prices, which is like a relatable experience, right? And also predicting the rent of a house. You know that predicting rent of a house depends on a couple of factors. Some include the geography, like where is this house located? What are the things in the house, right? Is it a two-bedroom flat? Is it a one-bedroom flat? What are the components, like and all of the other things really. So these are just like some of the real life applications of regression. Let me quickly talk about some common regression models. Examples include linear regression, right? What linear regression tries to do is that it tries to find a linear combination that best fits your data. Now, the data you're using in this scenario is a linear data. So, yes, linear regression models work very well with linear data. So, what you're trying to do is that what linear regression is trying to do is that it's trying to find the best linear combination. Now, linear combination, let me break it down and say, let me say linear equation. Let me put it in that sense, right? So it's trying to find the best equation that fits this data. Now you can see in this picture, right, this graph, you can see like these are data points, and then there is a line that kind of summarizes and then best fits this data. So that's what linear regression is trying to do. It's trying to find the linear combination or that line that best summarizes and fits this data. Right, so that's the idea behind linear regression. Now, lasso regression is a bit different in the sense that it's trying to find a subset of predictors that best reduce prediction error. So now, when your model learns, right, it makes it makes errors because the more data it gets, right, the probably the higher the accuracy. So the more it learns, probably the more it knows, and so what linear lasso regression, sorry, tends to do is that it tries to generate a subset of predictors that reduces the prediction error. So it finds like the barest minimum. So how does it do this? It does this by would I say pruning, in the sense that it tries to eliminate coefficients, right? They call them coefficients. So it eliminates its coefficients by reducing them to zero, right? So once a particular coefficient turns to zero, it eliminates it and then continues with the rest until it gets particular subset of of coefficients of predictors rather, and then these predictors would be what would be used to like make predictions. So same with regressor. The thing about multivariate regression and simple linear regression is that multivariate regression has a lot of features. Like I explained when I was talking about independent variables, right? So in multivariate regression, you have like two or more features, but in simple linear regression, you have just one target and one independent variable. And now, the other models I mentioned support vector machines, random forest regressor, decision tree regressor, exhibit regressor. Now, these models, they're okay. Aside support vector machines, random forest regressor, decision tree regressor, exhibit regressor, they are all decision trees. So they are not linear models because real life data, right, is not always linear. You will not always find a line that best explains your data. So you tend to use other methods. Now, these other methods, they're called decision trees. So now, what they do is that they are perfect for non-linear data because there's sometimes that you probably have your data and you plot your data points and then they're all just scattered everywhere. So they're non-linear. They can't a line can't perfectly divide them. So then you move them to regression models. decision regression models. Okay, so let me talk about scikit-learn a bit. Now, the thing is that scikit-learn is actually open source, right? It's built on NumPy, SkyPy, and Matplotlib, and it's a simple, easy to use, efficient tool for predictive data analysis. Now, scikit-learn is like it's a Python library, and it houses a whole lot of algorithms. Talk about algorithms for classification, for regression, clustering, dimensionality reduction, preprocessing, and model selection. So you can call scikit-learn to leverage a couple of algorithms, right? And we're going to be using them in um, in subsequent sessions. Okay. So now let me share my screen. So let's build a simple linear regression model. So I already have my VS Code opened already. I'm gonna share this notebook with you. So the aim of this workbook is that by the end of this workbook, right, you should be able to leverage visualizations to explore your data and get meaningful insights from your model. You should also be able to build a simple linear regression model and then plot the model predictions. So this is the link to download the data, right? Or if you have the notebook, you can just click the link here. So now, what the data set is about is the price of pumpkins over different countries. So when you download from this link, you get a zip file. So this zip file has like a couple of CSV files of different countries. So you can either combine all these CSV files into one, but for this example, I'm just picking one, the very first one. I'm picking the data set for Atlanta, right? And then this I'm going to use. So now the aim of what we want to do is that we want to be able to predict the average price of pumpkin in Atlanta, basically. So that's like the aim of this whole notebook. Right. Okay, so first of all, I'm sure you probably be familiar with pandas, right? So I'm going to use pandas to read the very first file. So here, these are like all the files here. So by my left here, you can see Atlanta, Baltimore, Boston, Chicago, Columbia, and all. Okay, so I'm using Atlanta, right? And then I name my data set pumpkins. So now, when you run the cell, right? So you're going to see commodity name, pumpkins, the city name, Atlanta, then the type, the package, variety, sub-variety, grade, the date, probably it was sold, the low price, high price, and a whole lot of other columns, right? So, um, so in all you have 25 columns and 5 rows, right? I printed the first 5. Okay, so now, let's get a bit of information about the data set. Okay, so you can see that we have a total of 57 entries. So this is a small data set, so it has 57 rows. Then you have the commodity name, the city name, type, and all that kind of that. You can also see that we have different data types. So some are objects, some are floats. Yeah, and then you can also see that we have missing data. So some columns are completely empty, right? So you can see zero, non null, which means that it's completely empty. So now, in situations like this where we have completely empty rows, we just discard them since they don't carry any information, basically. So a high level summary of the whole data, right? So when I do pumpkins.describe, it gives me a brief statistics of how my data set look like. So I can see the count, right? So those having zero point 0.0 shows that it's empty, it has no data. Then I can check the mean low price, mean high price. You can actually use this to see if there are outliers, right? So you check the minimum price, which is 14.5, the maximum price, which is 210. I guess that's USD. And then you can see mostly low, mostly high, and others, right? So let's see the amount of missing values we have. Some have 57 missing values, some 56, 57. If the whole row like is 57 and you're having 57, 56, you know that it's basically useless. So we're gonna discard all those with a lot of missing values. So so now we want to deal with missing data. So the in this data set, right, what we are most concerned about is basically the package. That is how is this pumpkin sold? Okay, some are sold inch beans, some are sold 1/6, different sizes. So we are concerned with how it's packaged because that also affects the price. Then we are concerned also about the low price, the high price, and the date it was sold. These are things we want to look out for. So now these are like the four columns we're interested in. Now remember that the targets, what we want to predict is the average price. But you can see that even in the data set, there is no average price. We don't have the average price, which is even what we want to predict, which is the target. So we have to like calculate this ourselves, right? So how do we do that? So now these are like the four columns we're dealing with, right? So yeah, so now let's calculate the average price. Now, what's the formula for calculating average, right? That is the sum of everything divided by the total number, right? So we have low price, high price divided by 2. That will give you the average price, right? And then for the date column, what we are interested in is the month. So we want to know what month this particular pumpkin was sold, right? So here I'm defining a new data frame using the dictionary. Then I'm saying month, I'm having package, I'm having the low price, the high price, and then the price, which is the average price, which is what we're going to predict, right? So now I want to do a bit of analysis here because package. Okay, let me print out package. Okay, so if I say pumpkins package, I want to show you the amount of the kind of elements we have because they are not evenly distributed. So now you can see that some are actually measured in 24-inch bins, right? Some are measured in 36-inch bins, then some measured 1 by 1/9 bushel cartons, right? So you can see that they are unevenly arranged. So now what we want to do now is that we want to okay, let me run this, right? Okay, let me sorry, let me run my notebook. So I'll be sure that I'm up to date. Okay. So now what I want to do here is that I want to okay, sorry. So now what I want to do is that okay, you can see that here you have this inch beans is not the same as this measurement here. So now I want to deal with it, right? So now what I'm saying here is in the column package in the pumpkin data, right? So now if the value contains bushel, right? Return the data set. So if I print pumpkins, let me run this, right? So this is what I'm going to see. So I'm going to see it returns to me all the um, data with bushels. So now I'm going to have to like clean this myself. So now what I want to do now is that new pumpkins, right? I want to now in the measurement type, right? 1/9 means that you're selling like whatever the price is plus 1 divided by 1/9. So I'm going to adjust the price based on the measurement type. So there are actually irregularities, and you can actually not detect these irregularities if you do not look closely. Now, the original data, right, houses has 24-inch bins, 12-inch bins. So I'm going with this as the standard measurement, right? But for this one, it's irregular, right? So I have to convert it and make sure that it's on the same level as the rest, right? So that's why I'm going to run this one. So now let me print the whole data set and let's look at it now. Now the price has been regularized and then it feels normal like every other one. Now, okay. So now we can proceed. So now let me just do like one or two visualizations. So I'm going to import matplotlib, right? And now I want to visualize the price versus the month, and then I want to plot a scatter plot, right? Now, looking at this visualization, you really can't uh, get any insight. It just looks like dots all over. So now, one thing I want to bring out is that you're not just going to be plotting random graphs, just to plot, just because you want to plot graphs. So you have to figure out what graph best explains a particular relationship. For example, you want to if you want to check the relationship between two categorical variables, right? A scatter plot is not ideal, so you may want to look at bars, like using bar plots. So bar plots best explains it also explains categorical variables, right? So now for this scenario, I want to check the price versus the month. So a scatter plot doesn't give me enough information. Right? So I decide to plot a bar chart. So another thing is that you probably would not have one specific library as a go-to all the time. So you just keep trying things out. Okay, what you're doing is trying to understand the data and understand and present it to yourself in the most easy to understand way. So you're making sure that you're not getting the wrong perception of what your data is saying. So I'm going to plot a bar chart, right? And now what I can see is, I think this makes more sense, right? So I can see the pumpkin price on this side, and then I can see the month, and I can see, oh, in the ninth month, it has an average price of 140. In 10th month, around 160. In the 11th month, probably around 110. So you can see that this makes more sense to as compared to the scatter plots here. Yeah, right. So yeah. Now I also made another one, right? I want to check the package, compare the package with the price. So when I used this package, right? So the price is low, right? When I use this particular package, you can see the price range here. It seems like it's more expensive than the rest. So now I think this kind of shows you that, okay, I think the way they pack it kind of affects the price. The measurement you're using affects the price. So this has kind of giving you a better understanding of how to treat the data. So now you can decide to, if after probably conducting your research on real world, right, and then you find out that probably it's just a particular location that has that, probably it just happened that it's in that location, or it just happened that that was just how it seems. Because sometimes your data might want to tell you what it's not, so you have to like check it out with real world factors. So you see that, okay, but what I can see here is that the measurement type kind of affects the price, right? So I want to take note of that. So you can check the unique values, all this, right? So now what I decided to do is that I want to make I want to make everything even. So now, you know that the month column has 9, 10, 11. Now, I don't want Python to see my month column as just a regular integer, right? I want to tell Python that this is a month column. It's not like 9 is greater than 10 is greater than 11. You know how Python counts, right? So I just want to tell Python that, okay, this is just to refer to something, just to indicate the month. So now what I want to do is that I want to make it equal. So whether it's in the ninth month or in the 10th month or the 11th month, right? I'm giving them an equal chance, right, to get sold. So I'm going to create, I'm going to do one not encoding for that. And for that, I'm going to use pd dot get dummies. And then I'm also doing one not encoding for the package column. So I'm giving everything an equal round, right? So one thing about using pd.getDummies is that you have to, unlike one not encoding, one not if you call one not encoding directly, it automatically removes the last column. So that last column is like a duplicate of an existing column. So now that I use get dummies, I have to like manually remove it. So if I do pumpkins.add, right? See what I get. I see low price, high price, which is the average price. And I see month 9, month 10, month 11. So now this month 11, the last one is usually a duplicate of um one of them. So I'm going to remove it, and then I'm probably going to remove package 36-inch beams, right? So I'm going to say pd dot drop. And what columns am I dropping? I'm dropping month, yeah, month 11, and then I'm also dropping package underscore 36 underscore, sorry, not underscore, inch print. I hope I get the spelling right. Then you have to specify the axis. So axis equals to 1. And then, okay, let me see my results before I check if it's supposed to true. Uh, maybe that's, sorry, I think it's true. Yeah, sorry. Okay. New Pumpkins should be the name of New Pumpkins doctor. Yeah. Put exits to full. Okay. I didn't get the spelling right, I suppose. So let me just copy this and paste it here. Right. Works now. Right. So yeah, it gives me what I want. So I can set in place equals to true. So instead of having to assign it again, I'm just input equals to true. So the change is affected on the new pumpkin data, right? So now in place equals to true, and if I check the data again, I can see that it's all gone now, right? So I'm good to go. I have converted all my categorical variables to numerical, right? So now the next thing I want to do is I want to take this data that I've transformed and cleaned, right? So let me be extra sure that there are no missing data, right? Okay. So how do I do that? I can say new pumpkins dot is null dot sorry it's null dot sum, right? Uh, so yes, sheet 000. That is, there is no null column, right? Then I can move on, because if there is a missing data, your model is going to throw an error, except you have a complex algorithm that automatically fills it for you, right? But since you are using a linear algorithm, yeah, it's not going to work. So now I'm going to remove the price. So the price is the target variable. Now the reason why I'm dropping the price is, okay, let me give this scenario, right? A lecturer walks into the class, sorry, into the exam hall with exam sheets, right? And then after distributing the exam papers, you also distribute the marking guide to the students. So it's like you are giving the students the answer to the exam question. So that is exactly what is going on here. So price is the dependent variable, and then the other factors, they are the independent variable. So I have to remove it from the data set before I can pass it to the model. Else the model is just going to learn, and then just like it's copying and pasting, and then you're going to be seeing probably 100% accuracy. But then of course it's wrong. The model learns the answers. So I'm going to be dropping it from the original data set, right, to specify the axis, and then I'm going to be assigning my targets to a new variable called y, right? Okay. So now, scikit learn, shortened as sklearn, right? I can import linear model. So now this linear model houses the linear regression model we're going to be using. And then model selection has a function called train test split. So now what I want to do is that I want to train and evaluate my model. Okay, let me paint this scenario, right? So I have my own data set, and then I have the answer, which is the price. But then I want to see how well my model, if I give my model a new data set it has never seen before, right? How accurate is this model? How is it going to give me my answer? Like, what is the accuracy? I want to measure that. Now, to be able to do that, I have to keep a part of the original data for testing. Then I would now feed it with um, that part I kept. Like, okay, give me a prediction. Then the prediction, I'll compare it to the answer I kept back, right? So that is the idea between train test split. So I'm trying to calculate trying to evaluate my model by keeping just a subset, just a small part, about 20% of the data back for evaluation. And then what I'm going to use this data set I kept back to do is going to predict, like test and see how well my model performs. Okay, so I'm going to run this cell. So I'm going to import it. Then now, what I'm going to do is, since I'm going to be dividing the x and y, which contains the independent and dependent variable, right? So I'm going to call it x train, which I'm going to use for training, x test, which I'm going to use for testing for the evaluation, right? Then y train for training, and y test for evaluation. And then I'm dividing it on test size of 0.2, right? So I run the cell. So now I'm going to import linear regression um, from the linear model, right? And then I'm going to fit it x train, y train. So you need to fit your model using model.fit, right? So what model.fit does is that it takes that algorithm and then fits it, trains it on the data. So it's training it on x train and y train. So what it's doing behind the scene is that it's trying to match the find patterns. Okay, let me put it that way. So it's trying to find patterns that, okay, for example, you have high price, you have low price, you have month 9, you have month 10. So it's trying to find patterns like how do these variables, how do they give this particular price? So it's trying to find patterns on how this variable gives this price. So that's what dot fit does. So after running it, I call model dot predict. Now I want to make predictions on my X test. X test is the data I kept aside, to test my model. So when I make prediction on X test, it's going to give me instead of prediction Y pred, right? I call it Y pred. Okay. So when I run it, um okay, this is just to check the shape. So now this is now let me see my white prediction. So this is the prediction that the model gave me. Now remember that I also kept aside white test. So white test is the correct answer to X test. So now I'm now going to compare the result of the Y prediction to the Y test, because Y test is the correct answer, like the expected value, and then Y pred is what the model gave me. So I'm looking at the first variable. The model said it's 150.008816, and then the current answer is 150.000. Okay, you can see that it's close, right? So you can see that the value is close if you keep comparing, right? So in subsequent sessions, you're going to be learning about you're going to be learning about model evaluation methods. You're going to be learning about probably we learn about how to optimize your model. Also note that this model was trained on a very small data set. I just picked one. So I would want you to merge the whole CSVs together, all these files, and then train the model. You will actually see that the performance would greatly improve. Yeah. So that is all. Okay, let me quickly explain. Oh, sorry. Let me quickly explain the challenge. So, with this data set, I want you to also build a lasso regression model. So, what I did here was that I used linear regression model here, right? Let me show you here, right? I said linear model dot linear regression. So I want you to read up on lasso regression. I want you to build a lasso regressor, and then I also want you to compare the results by yourself, and then please drop your findings on the Discord channel. I'll be happy to attend to your questions. So yeah, I guess that's the end of my presentation. Yeah. So thank you.